Hey guys, this is an examples video, and all we're going to be looking at in this video is functions and determining where they're continuous. So these are the three examples I'm going to go through in this video. So if there's a specific one that you're looking for, you can always fast forward to it. And you can also use this as a way to quiz yourself. So you could always pause here, try these out, and then hit play to see the answers. Okay, so starting with this first one. So where is this continuous? Well, what you're going to have to do with all of these is kind of investigate the function and then just think about if you can think of any areas where maybe you might have an issue with the domain. So what I mean here is when I look at this function, specifically this part right here, I know that I can't have a 0 in the denominator, and if I put in x equals -3, then I will get a 0 in the denominator. So I can't have x equals -3. There's actually a discontinuity there. So now I just need to note that in interval notation. So this is continuous everywhere else. So this is continuous from -infinity to -3, and then from -3 to infinity. So if you need a review of just how interval notation works, I will drop a link to that video in the description. So the next one is a piecewise function, and a lot of times people think that piecewise functions just means like, oh, well, you're not going to have continuities here. And that's not the case. So you actually really have to understand kind of the picture of the piecewise function. So what I recommend if you're not sure is actually just take a second to graph out specifically the points where the function is changing. So I've got, let's see, let me just go ahead and plot out a really quick graph here. And so let's start at 3. So at 3, if I'm going to be on the top function here, 1 plus x, so I'm going to have the point 3, 4, 1, 2, 3, 4. And then I move on to the next function, and this is just the constant function of 4. So sorry, this is 1 plus x, so I'm going to go up 1 over 1. Okay, here's the first part of my function. Then I'm going to have the constant function 4, and this goes from -2 to 3. So here's -2 to 3. So if you look at this, this is actually continuous here. And then at -2, I need to move down to this function. So 2 minus -2 is going to be 4 as well. And then I can go like this. So here's actually my piecewise function. So in this particular case, each time we moved to a different function, we actually didn't like have a discontinuity, right? Everything was connected. So this is continuous everywhere. And the way that you write that in interval notation would be from -infinity to +infinity. Okay, so for this last one, so let's graph this out one more time. So I've got, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so x is greater than or equal to -2. So if I plug -2 into this, let's see, I get 1, and then at -1 I'll get 0, and then, so this is actually going to be a little v like this, and then at -2 this goes down to -5, 1, 2, 3, 4, 5. So here would be an example of a discontinuity, right? So my discontinuity occurs right here, but otherwise this function is continuous. So this is really continuous on the interval from -infinity to -2, and then it picks back up from -2 and continues on. So that's kind of the key thing that you want to think about when you're thinking about continuous functions, is just what do you know about the graph, or what do you know about the function? If in doubt, graph it out. And so this is actually a very short video, but that covers it for this set of examples. If you have any questions, feel free to drop them in the comments. I'm always reading. Thanks for watching.